This is about the 20th paper I've written with Olivia and other co-authors on trying to show that private payout annuities, and I make it very clear from the beginning, I talk about irrevocable payout annuities, are something that makes sense, not only in theory, but also in practice. I would say, looking at our publication record, the theory part was well done. Now let's try again with the practical part. So, in the old days, defined benefit plan pays a lifetime income. These plans are at least outside the public sectors. These times are gone. And now we have these defined contribution plans. And few retirees, we know that, elect these lifetime payouts, which expose them to longevity risk, number one. And number two, they do not use the mortality credit, the extra return what you can receive if you give up bequest for a higher lifetime income. And we know that this giving up of bequest could push the payout return enormously. Few plan sponsors of annuities at the payout stage, and none offer real default annuities. There are some attempts where some part of your money is set aside so that there is a possibility to later buy an annuity, but a real default where we put people in to payout annuities, in irrevocable payout annuities, I don't see that at the moment. What we are doing here, we use a life cycle, theoretical, realistically calibrated life cycle model to design such what we are calling a pretty good default annuity. So looking back, there is a lot of work done to reduce institutional burdens, which spoke against annuities. In 2014, the US Treasury allowed participants to use a certain percentage and up to a limit of 401k assets to buy lifetime annuities, calling QLUC, qualified lifetime annuity contracts, starting not later than 85. In 2019, the Secure Act 2 makes it easier that employer can use a safe harbor for this QLUC annuity. In 2022, the Secure Act 2 raised contribution limits, removed the 25% cap on QLUC purchases. But at the moment, what we don't see is there is no possibility to make a default annuity. And while the market take-up rates are increasing, I would say they are still insufficient to overcome the reluctance to buy payout annuities. So there are many reasons why people are reluctant, many behavioral reasons, what I don't want to touch on in deep. But what we know, if something makes sense and people don't do it, a default solution is something which can help to overcome these behavioral biases, let's call them. So what we are doing, we evaluate pros and cons of including annuity as a default possibility in DC accounts. There are some proposals on some senators in Congress on doing that. It's not done. Lifetime income for employees was a proposal for a bill. We take on that and we try to show that defaulting a portion of retirement assets over a certain dollar threshold enhance retirement security for most plan participants, is cost effective to hedge longevity risk, and even small amounts can help retirees substantially. Our question is, how much of the retirees' accumulated tax-qualified retirement savings should be automatically used to purchase in an irrevocable payout annuity? Automatically means not mandatory, it's a default solution, they should be informed in advance, and so on and so on. But if there is no reaction, that in a certain point in time, we use a certain percentage. Questions are, should this default annuity be immediate or deferred? There is a wide range of possibility to annuitize. Immediate means starting benefits right now or to a later age, something like 80. What is the impact that households are heterogeneous, especially in terms of mortality, in wealth, and so on? And how to minimize utility losses from implementing such a default annuity. Because one have to say, maybe for some households, this is not a good, way to use the retirement asset. Maybe they have a disutility if there is an automatic annuity purchase. So how can we minimize these potential losses? So what we are using, we like to use as our framework to analyze things, to calibrate life cycle models. This is what we have done here and in many other papers. We include in this part many institutional details. I worked about 5 years in putting the US tax regime and social security benefits and the R&D regulation and the taxation of social security benefits. You know, I can speak on that for hours. It took a lot of time, but it's in the model, yeah, including labor income risk, and so on and so on. It's quite realistic, and we showed in other papers that this is good in line what data produces. So overall, what we are doing, we calibrate this for 18 different groups, male and female, 3 education level, less than high school, and college degree, and 3 preference settings. This is what we have done here. And then we define a default solution. So what is a default solution? So at a certain point in time, here we pick up 66. Yeah, we have to select a benefit start age. What kind of annuity should the money be defaulted? In a 67 starting age, in an 80 starting age, or an 85 starting age. So this means we have an immediate and 2 deferred annuity. What is the percentage of retirement asset? Is it 5%, 10%, 20%? And the last part is we use a threshold of retirement, of accumulated retirement asset as a filter to sort out these individuals for an annuitization is not a good idea. So this is what we are doing. And then we use our life cycle model to test welfare implication. So our approach, the plan sponsor can only differentiate retirees by observable factors, and the default solution must boost welfare of most plan participants while minimizing welfare losses in only few cases. This is what we are calling a pretty good life income annuity. Now it's the central part of my presentation. Typically I want to present only this table. Yeah, so how do you read now this table? That's a result of our life cycle model. So start with the blue box. The blue box shows the 3 types of default solution what we suggest. On the right side, DIA stands for deferred income annuity, starts at age 67. We use 20% of the retiree's accumulated asset over a threshold of 250,000, and we default them into a life annuity. Then in the middle panel, we have a deferred annuity 80, we use 7% over a threshold of 240,000, and so on. So what is inside the table? Inside the table is the welfare gain. How did we calculate the welfare gain? We run our life cycle model without having access to annuity. Then we run it again, and we put, in a certain point in time, at the age of 67, we put this default solution then into the life cycle model. And then we calculate at the age of 66 how better is the individual compared to a situation without having a life annuity. And the welfare approach means how much money you have to put into the 401k plan that the 2 individuals in this and the other world has the same utility. So what you see inside the tables are dollars what you have to put into the 401k plan to have the same annuity. Now let's start first with the left panel. The left panel is the situation where you use the immediate annuity as the default solution. I have 2 boxes. Box number, so number 1 is you see only positive numbers, which means everybody of these 18 different groups is better of having the default annuity. Female female college have the highest utility gain of about $11,000, which is a huge amount. On the other side, male with less than a high school degree, this amount is only $9, but at least it's not negative. For this person with a low income, typically also with a lower than expected life expectancy, they have not a negative utility if they use that. So number 2, now let's have a look to the middle panel where we have the deferred annuity until 80. It's better for the female college in doing that. So the welfare gain is about $12,600 compared to $11,000. So female college, for female college, the deferred annuity is better than the immediate annuity. Yeah? So especially for college-educated people, for people with a lower education, meaning lower life expectancy, lower 401k assets, and so on, then the immediate annuity is in most of the cases the better one. Then have a look to the right panel. This is the deferred annuity until 85. So, and we have a look to the female again, which produces a welfare gains of 11,000. This is better than the immediate annuity, but in all of the cases, the immediate annuity or the deferred annuity until age 80 dominates the annuity until age 85. This is what we can observe. Number 4, if you look now to the top panel for the females, yeah, females are always having a positive welfare gain. So in all of the cases, we have something where we are doing something good for the females. But, yeah, so if we are looking to the male with less than a high school degree, they have a negative utility. So this default solution produces a welfare loss and not a welfare gain. And now you can start to count in how many cases it is better, and so on and so on. You can compare that. I don't want to do this with you step by step. I give you the summary. So the immediate preferred annuity in 14 out of the cases is better is the most preferred annuity. The deferred annuity is only optimal in 4 of the cases. All retired do better with immediate annuity. So using 20% of 401k balance above a 250,000k threshold is what we are calling a pretty good default annuity. If the goal is to benefit as most as possible, we have to take into consideration that in the US, most people have a college degree. Yeah? If we are looking to them, then maybe, if this is the case, then we have to use the deferred annuity. Okay, let's summarize implications. Current rules require that plan participants be allowed to opt out of defaults are inconsistent with annuity risk pool. So the qualified investment default solution require that you can opt out but this is not possible with a payout annuity. Question is, should you change the law? Or another idea would be that the employer takes a part of the matching contribution, he has control over that, and put it into, in a certain way, into a default annuity. Last slide. Thank you for your attention. Yeah, and the propaganda material for Olivia.